Again, I apologize about the interruption. I almost fitted everything into the one video, but we have to add this ending here. So the point is that the argument via the Dedekind product theorem didn't give me any contradiction. So I start suspecting that maybe it is actually possible to do this. And then I remember from, like, I don't know, high school or somewhere, that the 6th root of 3 is the same as 3 to the power 1/6. And then a square root of 3, that's 3 to the power 1/2. And cube root of 3, that's 3 to the power 1/3. And maybe, just maybe, it's possible to find two integers, a and b, that would make this true. Let's see. Can I get such integers? So that would mean that 1/6 would have to be a over 2 plus b over 3. That's just how law of exponents works, right? Can I find such integers a and b? Well, if I clear the denominators, that means a is equal to 3a plus 2b. And now I remember the fundamental theorem of arithmetic that tells me that if I have two relatively prime integers, two relatively prime positive integers, I can always find some z-linear combination of them that give me 1. So there are such integers a and b because the GCD of 2 and 3 is 1. And in fact, now this is a really easy task, right? I can easily find what they are. Well, a should be 1 and b should be -1. So going back here, I get that the 6th root of 3 can be written as the square root of 3 times the cube root of 3, square root of 3, times the cube root of 3 to the power -1. In other words, it's square root of 3 divided by cube root of 3. Oh, and this surely does belong to this field. Okay, so I can write the 6th root of 3 as the ratio of these two. And the ratio of these two belongs to that field, right? Because again, this is a field, so I can take, surely square root of 3 belongs to this field, and cube root of 3 belongs to this field, so their quotient also belongs to that field, because it's a field, so I'm allowed to divide. So, but everything in this field can be written in such a way. Right? If you just write out what the elements of this field look like, you'll get exactly that expression. So, and every element of Q adjoin square root of 3, cube root of 3 can be written as above. The as above meaning this. Did I find A, B, C, D, E, F? No, I didn't. But because I was able to write the 6th root of 3 as this ratio, and I know that this ratio belongs to this field, I know it's possible. I know that A, B, C, D, E, F exist. I didn't write them down, but I know they exist.